Alright, so we're on day 20. Let's go over here and copy the heap over to 20-stl heap. Alright, what do we have? Ooh. Hey, look at that. So there's our heap, print, put, and remove. Okay, well what else do we have? Heap.cpp. Okay, great. So, let's delete all this code from before. Alright. So if we're going to put, which in this case is at, oh yeah, let's go ahead and make sure we fail our test case. I forgot what it was called. Simple dash test. Total failure. Perfect. Okay. So if we're going to put something into the heap, it's actually not that bad. We simply go over here. You can, if you already have a vector, you can call make heap to turn it into, but this, we haven't added an element to our vector yet, so we're not going to do that. But if we wanted to, we could push back and then push heap. I'm just going to copy this line of code right here, go over here, put it in here, and then replace 99 with val. What's happening? Well, we push a value to the back of the vector, and that may break the heap property, but remember it maintains balance and left justified by putting it there. And then we're going to call push heap, which is basically telling the STL to sift up that last element and turn it into a heap. Okay. And then what was the next one? And then if we want to pop, we can pop the heap just like this. And then pop back. Ooh, so it's two functions? That's kind of amusing. All right. Oh, well, we got to remove it. Okay, so what we want to do, we're in here. We want to int ret equals v dot back and then return. Okay, let's see if that works. Nope. Oh, v. I guess I should call it something. Well, I didn't quite mean to do this for you, but that's kind of what happened. Yeah, we're almost there. Push heap is not a member of STD. I think it's a algorithm, is that right? Vector iHost algorithm, perfect. Algorithm. All right, so this is where things get a little tricky. So expected 10 was 3. Well, what's happening is down here, if we're pushing 3 to 10 and then we're asking for 3, well, this is a heap in the STL does it the other way around. It does it from least to greatest. So this one's going to be a little different. So in fact, it shouldn't be getting back 10, it should be getting back 3. And that means down here, we should be getting back 2. Actually, it should be getting back, shouldn't be getting back 2? That's what it should be doing. Hold on, whoops. Expected 2 was 3. Yeah, so something else is going on. Put 2, put 10. Well, let's see. So we push the back, and then we push the heap, and then we get the back, or do we want the front? Or we may want the front. Expected 10 was, okay. All right, I lied. I was looking at it in reverse. Sorry about that. I forgot to get the front, and then, oh yeah, so it made the largest. Ooh, that'll be tricky. All right. And now, oh, so we're done. Okay, I didn't mean to do that all for you. But anyways, as you can see, hopefully it's not that complicated. Really all that's happening is when you do a pushback or a popback from your regular vector, you need to apply the heap function either right afterwards or right before in order to make it work. Okay. Well then. Oh, here we go. If you had a full vector, you can populate a vector with a bunch of elements and then just call make heap and it will heapify the entire thing. The maximum element is going to be in the front, and then you can push back at 50, push the heap again, maximum element's still the front, and then you can pop the heap to delete the maximum element, which is the front. You actually didn't have to pop back yet. And then you can call front again. Okay. Nice slides. Let's hide that. All right, here we go. Make heap. Heapifies the entire thing. If you want to push, you have to call both of them. Pop heap actually removes the first element and reheap. You don't have to do the pop back if you don't want to, but you're free to. Front to get the top element. Sort the heap actually calls heap sort. Is heap will tell you if your current vector is a heap, and is heap until will return an iterator of what part of the vector is still a heap in case you start accidentally adding too many elements. Okay. Comments. So, priority queues data structure is designed to return elements in order of priority. Efficiency is usually measured by the sum of time it takes to add and to remove an element. Excuse me. Simple implementations take O of n. Heap is log of n. Thus, for any sort of heavy use, a heap is usually better. By the way, this priority queue data structure comes up a lot in algorithms. There's a lot of graph algorithms that take a very long time, but if you add a priority queue and use a heap, it actually improves the efficiency substantially. So just keep in mind that the heap does pop up in the most random of places where it becomes very useful, although it's not generally your go-to data structure. All right, and then the author of these slides defines doing things this way. All right, the end. Okay, any question about a priority queue? All right. Close.